Good morning, friends. Today we are going to discuss about the introductory part of metal forming process. Metal forming is very relevant because huge amount of work of metal is done through metal forming process. It is a very productive process and a lot of industrial applications. Many of the things are done by metal forming, and that is the source of all sorts of manufacturing related to many metal forming operations. So it is so significant, and that is why needed to study all those things at length. So the next one is the classifications of metal forming. So metal forming primarily classified between two divisions. One is bulk deformation, another one is sheet metal working. What is bulk deformation? Bulk deformation means that where surface area is less, volume is more. So that is bulky. And wherever surface area is more and volume is less, that can be termed as sheet metal working. In case of bulk deformation process, they are mainly divided by four very popular process and tremendous application in metal forming business. The first one is rolling process. Rolling process where rolls are rotated in opposite direction, and that is responsible for giving shapes, calendars, or different kind of foam rolling, thread rolling, skew rolling, and many shape rolling, many other kind of activities. Hugely productive process. Continuously we can produce a lot of materials out of that. The next one is forging process, where by force that can be gradual, pressure that can be impact, and through which we can give shapes to different metals depending on its ductility in the plastic region, and according to that we can produce. And there are different classifications like, say, open die forging, closed die forging, flashless forging, and all sorts of things. That is also a very productive process and very popular. The third one is extrusions, where again the die with a plunger, all those materials are forced so that it will come from the die, taking the shape of the die. A continuous process, highly productive process. All those pipes, solid rods, and all those things can be easily produced by extrusion process. A huge amount of productivity is possible. The fourth one is wire and bar drawing. Instead of pushing, pulling again the similar die, so the wire are easy to produce by these things. So some outlet is pulled against the die, and according to that wire and bar will be produced, but it is an iterative process. We cannot step down very big diameter to a thin wire, so we have to do in a step by step. So that way it is implemented in a wire and bar drawing process. These are all main classifications of bulk deformation process. And the other one is sheet metal working, that is associated with many processes. One is bending operation. Sheet metal will be bended against some die or some kind of device. Then stretching, it is extended and stretching against definitely some kind of die. The third is deep or cup drawing, where with the plunger will certain distance, and according to that the deformation will take place. Then shearing process, whereby cutting all those things associated. And the fourth one is miscellaneous process, many kind of edge preparation, hemming, aging, curling, and many other processes are also related to the sheet metal working. So one can see these sketchy representations of those metal forming process. The first one is forging. This is open die forging. The part is the bottom die is stationary and the open die is moving, and they are pressing those materials, and the shape and dimensions are getting changed. Mostly done in the hot elevated temperature, but it can be done in the cold one also. The next one is rolling. As we have discussed, there are two rolls in the opposite direction. They will rotate, and because of their friction associated with those slabs, They will just act as a pulling agent, and according to that we can change the dimensions, we can reduce the dimensions, and we can impart some kind of impressions of these shapes. The third one, this picture is typical wire drawing, where again this material is drawn against the die, and die will give the proper shape. So wires and bars are produced by this process. The fourth one, top series, that is extrusion, where with a plunger forcing the material against some short opening, that is called die, and while coming out of it, it will take the shape of the die. So that way the tubes, hollow tubes, the solid rods, all those things also can be done, and productivity is enormous, huge. It can be employed for many industrial applications. The next row, left deep drawing with a plunger against the die. It will just force that to have some depth and deformation. This is known as deep drawing. You are just pulling, but because of the depth, it is called drawing, deep drawing. The next one is die. With the die, it is stretching, putting this metal plates and slabs, and they are stretched together in order to deform appropriately. The next one, easy one, it is bending. Again, the plunger with a typical type of die and the symmetrical loading, it will ensure the bending of all those plates and slabs and sheets. The last one, it is obvious, with a shearing, the movement of those two supporting structures, and that way the shearing, just like scissors, it will shear and cut those materials. So this is very popular for sheet metal working process. So we can see with those types of all those colored representation, one is bending, then deep drawing, then shearing, then rolling, then forging, this extrusion and wire drawing, and all those materials are printed in blue color so that it is easy to identify this workpiece. It's a very good representation of the basic sheet forming processes, and very popular for the sheets and also some kind of the metal forming. The next one is again the representation. We can see all those die, open and closed die, they are coming out of those products. We are seeing those extrusions, we are seeing rolling, we are seeing drawing, and all sorts of activity with some color representation for better comprehensibility. Next, again also representation, these rolling process where the forces are given by those rolls, the top rolls and bottom rolls, and the workpiece is fed into that, and with this friction between the work material, these billets and the rolls, it will just pull through, and with some velocity we can get the deformed dimensions. The next one is open forging. With a top one, it is moving. The bottom one, it is just stationary. It is having some internal cavities, and because of the pressing, mostly it is done in the elevated temperature, so that is called hot forging. Force with velocity, they will change the shape depending on the internal cavities of the die. And the dies are made of HST alloys. These are called high strength temperature resistant alloys. Not easy to machine because it has to withstand the extra heat from the workpiece so that it can retain its hardness and strength. The material of HSTR will be higher hot hardness and hot strength. The next one, bottom line left, it is extrusion. With a ram against the die, it is pushing the workpiece, and we are getting some shape depending on the internal diameters, cavities of the die. And the third one, the difference between extrusion and drawing is that in extrusion we are pushing with a ram, and drawing we are pulling. So drawing is pulling, extrusion is pushing. And we can see the different types of extrusions. Extrusions also can be of different varieties, and 4 varieties are represented. The first one is direct extrusion, second one is indirect extrusion, third one is tubular extrusion, and the fourth one is hydrostatic extrusion. The four things are having different kind of subtle applications in terms of the products. The first one is direct extrusion. Direct extrusion means that wherever the direction of the ram and the product delivery will be collinear, that is direct extrusion. Plunger is pressing the material and material is coming out of those die in one line, and that is called direct extrusion. The second one, first line, that is called indirect extrusion, where these plungers are giving against a container and container is coming out in the direction, although from this container the workpiece material is coming as per the die in the opposite direction. The pushing is done in one direction and in opposite direction, though it is collinear, but in the opposite direction. In case of direct, it is the similar direction. Opposite direction, the product is coming, and typically this is known as indirect extrusion. The third one is tubular extrusion. So ram is forcing a typical mandrel. Why mandrel is there? Mandrel will ensure that the hollow tubes and pipes will be produced. So mandrel will ensure that in its circumference against the die, the product will come out of it, and the cross section is shown, those tube or pipes, hollow sections. So this is also possible. This can be circular, this can be rectangular, this can be any other kind of shapes, but hollow. For hollow construction, we need mandrel, and this mandrel is pushed by the ram with certain velocity and forces, and that way the tubes and pipes are extruded. Very, very popular process, producing pipes and tubes. And the fourth one is hydraulic, where hydraulic fluids are there. Hydraulic fluids are pressed against the ram. Ram is not directly pressing those material. Hydraulic fluid is pressing the material. The advantage is that hydraulic, it gives a very, very enormous pressures, but it is stepless. It is uniformly because of the Pascal's law, and they are pressing those material against the die, and the die is coming out. Die is ensuring that the material is coming out, and that way the product is produced, and this is called hydrostatic extrusion. So it is, ram is not physically mechanical contact, it is with a fluidic contact associated with the raw material, and the fluid is giving the pressure and the ram is giving the pressure to the fluid. Very uniform, stepless pressure can be given. That also have some certain applications. Now we can see these, all those sheet thinning, how the sheets and other things are thinned, then how these other part of will be just having a different dimension, that is called upsetting, then the forging, then coining, so how the coins and other things are given shapes, or some kind of embossing is also possible. The 3D profiles will be generating with pressing of it, then the flow forming wherever it is flows, and against some kind of rotation against the tool, so it will be flowed and given some kind of shapes. Then orbital forming with some eccentric load, so some kind of typical shape, some boss forming, extra protruded portions and all those things, that is also possible in case of those kind of operations. Many applications. Now we will discuss a little bit about the rolling activity. What is rolling? Rolling is the process in which the metals and alloys are plastically deformed into semi-finished or finished condition, passing between circular cylinders. Circular cylinder surfaces are responsible for producing those plastically deformed surfaces with dimensional and shape changes. Very productive process. And the frictional force comes from the metal and the rolls, depending upon their temperature also. So metal changes its shape due to high compressive force. Compressive force is responsible for changing the dimension, just like the bread preparation, the classical bread preparation in our house by our mothers and sisters. They are rolling, but other part is not a roller, it is a flat, and one is roller, and according to that the shapes are changed of a viscous elastic material of the wheat dough. So here more forces are required, that is why 2 rollers are required in case of metal to deform in that very fashion and with high compressive forces. And both hot, where drastic shape changing is possible because temperature is responsible for lowering the yield strength, so that the material becomes yielded at lower temperature, so less forces are required. That is done in hot rolling, and cold rolling is also done where very good finish is possible, dimensionally accurate and very good surface finish, and sometimes strain hardening is also there. But the problem is that it will require a lot of forces depending upon the capability of the material. All metals cannot be cold rolled always because huge amount of forces will be required and depending upon their yield strength. And there are, from the start point, it is ingot, then blooms, then billets, then slabs, which are further rolled into the plate. It is a spelling mistake, it will be slabs, S-L-A-B, not P. Slabs, plate, sheet, rod, pipes, rails, all sorts of things. The shaped product also is possible from coming out of this thing. Next. So we can see the rolling process, and rolling process is changing the grains from bigger grains changing to the laminar grains and then very small grains, and the strength and all those things will be there. So we can see from the next slides where ingot with non-uniform grains, wrought product with large grains, then they are transforming because of the pressure of the roll, elongated grains, new grains forming, new grains growing, recrystallization takes place and all sorts of things with small or uniform grains, and there is sometimes an intended one. So grain structures also gets changed in hot forming process, specifically hot rolling process. We can see the angle of bite, and that is important. This is along the arc and the alpha is the angle. The arc corresponds to the central angle alpha and called angle of contact or bite. Bite means it will just pulling forces, and that angle is very important to determine how much pulling force will be there. And the friction rolling is possible, and this limiting case is a straightforward equation where P sine alpha on the basis of this angle of contact is equal to mu. Mu is friction coefficient, Pu cos alpha, and from there we can get mu is equal to tan alpha, and alpha is equal to tan inverse of mu. So various values of alpha and other things are associated with what kind of deformation we want to proceed. And depends on, sometimes lubrication is also added in between the plates and the rolls so that appropriate smooth running will be there, so that it will not adhere to, the workpiece will not adhere to the rolls. That is also sometimes relevant. If the other surfaces of the lubricant surfaces are there, it is ensured that it is not adhered with that. So it will reduce the friction and adherence and other things will be reduced. So, and all those things also depends upon the temperature. So what type of temperature? In cold rolling, the coefficient of friction is very, very less, as 0.1. Warm working, little bit higher temperature, it may be 0.2, but in hot rolling it is around 0.4, and sometimes streaking friction is also seen, and then the friction coefficient becomes 0.7. So there are a lot of friction, and then there is the possibility of adherence of all those work material with the roll, and that is deadly. That is why the lubrications and other things are there to create some kind of liquid interface between the roll surface and the workpiece material, so that it can be pulled very easily and no problem of the adherence. In sticking, the hot surface adheres to roll, and thus the central part of the strip undergoes with a severe deformation. So we don't want that kind of sticking. So severe deformations, cracks and other things will be there, and material will be rejected. So we can see all those diagrams in the teachers. Ingots are coming to the bloom and slab, and from bloom to billet to bar, say other bloom to billet to some structural shapes with structural rolling, and then slab with some thickness control, plates, sheets and strips. So these will be formed from the operations. And the definition of the bloom, it can be, the cross section will be 150 by 150, one standard infinite length, and or maybe 250 by 300 where it is not a square one. So that is the standard size of two sizes of blooms, and billets will be, it is reduced one, cross section 50 by 50 or 125 by 25. And for the slab, the width is more, the thickness is limited. Similarly, so three slabs width may be 300 to 1500 millimeter, that will be called slab. And plate more than 6.35 millimeter, it will be plate, and the sheet will be less than 6.35 millimeter, it will be sheet. And the strip will be 6.35 millimeter and the width will be 600 millimeter. That is the standard definition of strip. And the foil, the thickness will be less than 1.5 millimeter and the width will be at least 300 millimeter. So these are all standard definition available in Bureau of Indian Standard books for the Indian standards, Indian manufacturers, and these are the things. Some companies are very specialized in foil producing, and that company was known as India Foils. They were having their factory at once upon a time in Kamarhati, and they were market leaders in terms of manufacturing foils for all those food products and hygienic packaging part of it, and that is known as India Foils. They are producing those foils in large quantities from their factory at Kamarhati. So we can see all those diagrammatic representations on the slabs and blooms and billets. So different structural shapes, rails, bars are coming, these scalps are there, and pipe and tubing, those large diameter pipes with some joining, then tin plates, then seamless pipes, and wares and other things are also the initial raw material coming from those billets. Billets are blooms and slabs are produced maybe from the continuous casting line, and from there itself it is subdivided into the different kind of rolling elements and shapes and rolls, and from there itself it is the different applications are produced associated with that, both for cold and hot forming process. This is the different kind of shape rolling activity. We can generate all those rails, edgings and other part of it, the roughing, horizontal, vertical rolls, some kind of intermediate horizontal rolls, edging of those rolls, finishing all those things, and sometimes a very near net shape manufacturing or net shape manufacturing process is also possible by these kind of shape rolling activity with the different configurations of those rolls. We can see some of the flat rolling processes. Some schematic diagram is shown, strip of thickness, of definite thickness of H0 with some roll gap, it is introduced with some velocity V suffix R. Velocity of the strip increases from its entry value and enters the roll gap, and with some maximum speed, and those things are calculated to find it out, the productivity and the deformation characteristics in the rolling process. So we can see all those forces in contact length, in the width of strip, into average true stress, and that is determine all those forces, and the power is associated with those pi into 2 into force into length into speed in RPM by 6000. So all those things are equations, and from there itself we can calculate the power per roll, and that is sometimes required in order to identify the real power requirement of those rolls and the capability of those machines in order to process that kind of shape deformation. And very productive activity that is called thread rolling. Thread rolling, 95 to 98, maybe 99% of the threads are produced by thread rolling activity. It's a very productive activity. It is a mainly cold forming process. Straight or tapered threads are formed because of the shapes. Typical type of shapes or rolls are there associated, and threads are formed on the rod or wire with each stroke of a pair by flat reciprocating dies. Reciprocating dies, they will go for that, fix up, and according to that, with the hard impression, they will create all those things, rotating and squeezing between the hardened steel dies with typical shapes of the threads depending on their pitch. For each and every pitch, there are separate dedicated set of dies, and according to they put some pressure and squeezes, and the threads are produced in a higher quantity, and no raw material wastage will be there, as it is done with the thread cutting operations in turning or any other kind of machining process. That is the beauty of it. Immediately threads will be there. The problem is that you require a die for a very specific thread pitch and those kind of configuration. Displaced material forms the roots of the thread and at the same time force radially outward to form the crest. So, the same material will be formed, compressed and formed, and the die penetrated on the work. So, these will create the impression on the workpiece, permanent impression, long lasting impression, and that is a very productive one, because huge amount of threads and other things can be produced within no time, and that is why thread rolling is very popular for all those top level players in terms of producing all those high tensile nuts and bolts like TVAC and Breco. Their nuts and bolts, thread rollings are there in case of external threads, in terms of internal threads and different varieties of thread. So, terrific process. All those nuts and bolt manufacturers like TVS or Breco, they produce those thread rolling activities in order to do that. And that's all for today's session. We have discussed elaborately the introductory part of the classifications of all sorts of metal forming process. Thank you for your patient hearing.